My name is Dong Wing and I'm from the LN2 Institute. It's based here in London at the British Library, and I'm also affiliated with the University of Edinburgh. So my background is computer science, but I've been working on a lot of projects with social scientists as well as humanities scholars. And so today I'd like to give you an example of two studies that I worked on, as well as discussing some challenges that I encountered in doing this interdisciplinary text analysis. So just before I continue, I'd like to spend one slide on the LN2 Institute because it's fairly new and I wasn't sure how many of you actually have heard about the LN2 Institute before. So it was created in 2015 by 5 founding universities: Cambridge, Edinburgh, Oxford, UCL and Warwick. And now it has expanded to 13 universities. It started as the National Center for Data Science, and in 2017 we also became the National Center for AI. And it's based in London at the British Library. There are a lot of public events as well as workshops, talks, etc. So if you're interested in data science as well as computational science, I would recommend keeping track of the website as well. So what I really like about the touring is that it's really interdisciplinary. So I have a computer science background, but a lot of my colleagues come from social sciences. Some have a law background or philosophy. So it's a really interesting environment to work in. So to motivate my research, and of course it's a simplification, I like to start with data, because data drives, I think, a lot of research that I'm interested in and what I'm doing. And so in the social sciences, a couple of methods that are frequently used to collect data are, for example, surveys, observation. So a researcher might go into a community, talk with community members, as well as interviews. And these methods really give you really rich, deep information about the participants that you're interested in usually. But unfortunately, they are also very time consuming. It can sometimes take multiple years to collect the data, and then the data set that you end up with is still pretty small, especially for the standards in computer science. Maybe a bigger problem is what has been called the observer's paradox by Labov, who's a linguist. And he says that if you're interested in analyzing language or social behavior, then a lot of times you want to study people when they don't know that they're being observed, right? So for example, when they're talking with their friends in a pub, or when they're with their family at home. But then when you give them a survey, or if you observe them, or if you interview them, usually people know that they're participating in some study. And so you have the risk that they might alter their response to what they think the researcher hopes to see. And this is a really big problem, and of course a lot of researchers have thought of coming up with clever ways of trying to minimize this effect. But I think this is where big data can really complement or bring in new insights to the study of social and cultural phenomena. So I'm really interested in social media data. I work a lot with Twitter data, for example, but also you can think of Instagram or Facebook, etc. You can think of all kinds of digital data that's generated by devices, of course, but also, for example, existing collections like books that are now digitized and becoming available for researchers. So what I'd like to talk about today is something called operationalization. So in a lot of studies that we do in the social sciences, there's this step where you're translating some social cultural concept into something that you can then measure, right? This is a key step in a lot of studies that you're doing. So operationalization is this process of developing measures. So you can think of, well, you'd like to measure how happy people are, or you like to measure hate speech in social media, or you like to measure policy positions. These are all very rich and very complex concepts, but somehow you then want to develop a method to kind of quantify this. And this is a key challenge where I think NLP can come in, but also where we need to interact with social scientists and humanities scholars. So this is a typical process of operationalization. You start with the concept. You're then going to develop measures. Sometimes people call it indicators or operationalizations for this concept. And then you're applying them to your data. And then you're going to analyze this to explore and answer your research question. And so some people, for example, at Koch and Collier, two political scientists, they divide the very first step in 2 different steps. So they say, well, you start with the background concepts. So this means all the different meanings or understandings that a particular concept entails. And then you define a specific formulation of the concept that is relevant to your study and your data. So that helps to make it a bit more concrete before you develop the real measures. And I think in this operationalization step is where NLP can come in. So when you're not doing computational analysis, you might be doing human coding. This is something that a lot of people are familiar with. But you can also use NLP in this step, and this is what I'd like to talk about today. And so I think NLP can, on the one hand, help you to scale up analysis. Human coding is very time-consuming, but also NLP can help you to find or measure patterns of language or behavior that are sometimes so fine-grained that you can't really notice it when you just manually read the text. As an example, you might be interested in the writing styles of people, and then you don't want to look at the topics people write about, but maybe really the function words that people use. But if you just manually read through text, it's really hard to really find key patterns just based on function words or other types of words. But then NLP can help you to really extract patterns by looking at large amounts of data. So it's not only scaling up, but also finding things in the data that you wouldn't be able to find if you just would look at it manually. So actually, I want to ask how many of you are familiar with machine learning? Okay, a fair amount. So I wasn't sure, so this is just one slide to explain one type of machine learning, which is called supervised machine learning, and this is what I'm going to talk about today. But there's certainly other types as well. So the idea is that you start with data that you have labeled. So for example, if you like to train a classifier that can automatically detect spam or not spam, you might give the model lots of examples, lots of email messages, for example, that are already labeled with spam or not spam. But you can also think of social media messages labeled by whether they contain hate speech or not, or all kind of other labels. Then you're going to separate your data into at least two different sets, a training set and a test set. Sometimes people also have a development set, or they have more sets, but in general you need to have at least two different sets. And then you're going to develop your model just based on the training set. So you could train a logistic regression classifier based on this, but you could also train a deep neural network based on this, right? The idea is that the model that you train, for which you estimate the parameters, is only looking at the training set. And then you're going to validate the model by giving it data that the model hasn't seen before. So that's going to be the test set. And then if the performance is good enough, you apply it to all your unlabeled data that you might have, which might be thousands or millions of documents. But actually determining whether something is good enough is also a very tricky problem. But this is a general pipeline that you might use. So today I'd like to give two examples of studies that I worked on, and then end with actually mostly challenges, I think, and also why I think we need more interaction between social sciences and NLP. And so the first one is a study with social scientists in the Netherlands about the Movember campaign. So who of you is familiar with the Movember campaign? Yeah, I think a lot. So do you actually know what campaign stands for? Or so the Movember campaign runs in the month of November, and a lot of people know it because it encourages men to grow a mustache, and then you can support these men by donating money. And the campaign focuses on, well, they used to focus a lot on cancer, but then they also extended the scope by looking at men's health as well, of mental health as well. And so when you look at the campaign, you see that a lot of people join up to participate in the campaign. But then some people raise a lot of money, and some people raise no money at all. And so for social scientists, it's really interesting to understand or explain why some people raise more money than other people. And this is the question that we started with. And the idea was to look at the reasons why people participate, because there's this idea that the motivation of people to join the campaign can have a big effect on how much money they raise in the end. And so we used this model called the social identity model of collective action, which was proposed by Van Zomer et al. In 2008, which is a model proposed in the social sciences. But then we want to quantify this using computational approaches in the real data that we got. So the model identifies three different motivations for people to participate in these campaigns. The first motivation is called the injustice motivation, which is a shared emotion that includes both affective and cognitive perceptions of an unfair situation. And in the context of the campaign, you could think of phrases like, well, I had testicular cancer, my dad, because men's health is important to me, etc. The second motivation is called the social identity motivation. And this means that if you're participating because your friends are participating, for example, or you want to have an excuse to go much test, etc. And the final motivation, the collective efficacy motivation, is the fact that you're participating because you believe that that the campaign can make a difference, right? So the nice thing of the Movember campaign is that people who participate have a public profile, and in this public profile they have a text field in which they explain why they participate in the campaign. And but of course the text that's provided here is a free text, it's not structured. So what we want to do was, well, can we automatically analyze this text to identify these motivations that I just discussed, and can we then link them to the amount of money that people raise and see if there's indeed an effect. So here are the three steps that we took. First, a sample of the data was annotated and the codebook was developed. And so this is where really my social science collaborator came in. And so we collected a lot of profiles from the website. Actually, it was in collaboration with the Movember campaign. So they gave us the list of members of the two countries that we focused on, UK and US. And so we started with annotating a sample of the data, and these were the inter-annotated agreements that we got in the end, based on 200 motivations that were annotated by two people. And so you'll see that the injustice motivation was the easiest to annotate, was highest agreement, and the collective efficacy had really the lowest agreement. And that was also because I think the collective efficacy motivation was quite broad. So it was quite difficult to find, to sometimes decide whether it belongs there or not. And also I need to note that these motivations are not mutually exclusive. So one person can have multiple motivations, right? And then this is the data set that we ended up with. We annotated a little bit more than 2,000 of these motivations with these type of motivations that I just described. And we separated them into a train and test set because we want to train a classifier. We then developed a classifier, and it actually was a really simple model where we just used logistic regression, so something that you might be familiar with. But instead of using a small number of variables, in this case we used thousands of words, as well as sequences of words as features. And so these were the features that the logistic regression classifier gave the highest weight to for each of these motivations. So what we did was, for each motivation, we trained the classifier to say whether the motivation was present in the text or not. Because these motivations are not mutually exclusive, we trained 3 different classifiers. And so for the injustice motivation, you find words like cancer, friend, etc. ranked really highly. And also a topic with words about family and friends. For the social identity motivation, words like fun, team, and mustache were ranked highly. And for the collective efficacy motivations, words like beat, family, change, etc. And then if you look at the performance of the classifier, so we looked at the output of the classifier and compared them against the manual annotations, we got these numbers. So F1 is just an evaluation metric that is used a lot in machine learning. But what I think was most interesting is that, again, we find that injustice motivation had the highest performance, and the collective efficacy motivation had really the lowest performance by this machine learning model. And this is what we often find, right? If humans disagree more, it's also more difficult for the computational model to learn from these annotations and to pick up the right patterns. And so for the injustice motivation, we had the highest agreement, and for the collective efficacy, we had the lowest agreement. And this also corresponds to, in the end, the performance of the models that we ended up with. And then we applied these classifiers on the complete data. So we had about 90,000 profiles for which we applied these classifiers. And then we found that campaign participants with an injustice motivation indeed raised significantly more money than participants with these other 2 motivations. Also, we found that participants with a social identity motivation were more often part of a team. And when they were more often part of a team, they also raised more money. And so we have been working on follow-up work, looking at also social network structures, etc. But this was more like a first study on looking at motivations and how people participate, and an effect on how much money they raise. Are there any questions about this part? Okay. Oh, I think you have to enter it into the app. I'm sorry. Okay. The next study that I like to discuss is one about Folktale. So it's really different, but this was a project that I worked on with Folktale researchers. And so with Folktales, you can think of, for example, fairy tales like Little Red Riding Hood, but also, for example, urban legends, The Killer in the Backseat, and there are a lot of other stories as well. And these folktales, they get transmitted over time, geographically, often orally, but also increasingly written, for example, on social media. And so sometimes we see really similar stories appearing, right? So for example, the first one, so this is just a summary of a story, it goes like this. A car driver picks up a hitchhiker. They talk about spiritual topics and life, and suddenly the hitchhiker vanishes. The police tell him that they've heard the story earlier that day. Then this is another story. A guy bikes through the park at night. He encounters a girl covered in blood. On their way to the police, she suddenly disappears, and she resembles a murdered girl. Then we have a car driver picks up a hitchhiker and borrows her his sweater. When he stops by to pick up the sweater, he discovers she passed away due to a car accident a while ago, and he finds his sweater on her grave. And the first story goes like this. A car driver picks up a girl wearing a white dress. He accidentally spills red wine on her dress. The next day he finds out she died a year ago. When the police open her grave, they find a white dress with a red wine spot. So I think, yeah, you will notice there are some similarities in these stories, right? But also differences. For example, how the hitchhiker is portrayed. In the first one, they're talking about spiritual topics. The second one, it's a murdered girl. Third one, the hitchhiker passed away due to a car accident. And the fourth one, we don't know how she died, but we know she died a year ago. There are also differences in the vehicle involved. We have a car, we have a bike. And there are also differences in the clothing that is mentioned. But still, you would say these are actually very, very similar stories, right? And so Folktale researchers are really interested in these stories and how different variants of the same story might emerge over time and how they might spread geographically, because stories get adapted towards the audience, the culture, etc. And so Folktale researchers have developed these classification systems to organize and analyze these stories. And so these four stories would all be categorized according to their classification scheme as the vanishing hitchhiker. And then there's what they call a tail type index, and this story has the number 1000. So they would say that all these four stories are actually the same story categorized with that particular ID. And there are different classification systems. This is probably the most famous one, the tail type index, the Arne-Thompson-Utter classification system. And so Red Riding Hood is included in this one, but also the race between hare and tortoise and other stories as well. Another popular categorization index is developed by Brun Funds, and it really focuses on urban legends. So you have stories like the microwave pets, the kidney heist, the killer in the back seats, the vanishing hitchhiker, etc. So what we want to do as a first start was, well, can we automatically analyze or automatically identify these tail types? So given a new story, can we say, well, actually this is just the killer in the back seat? Or given another news story, well, this is actually just a variant on Little Red Riding Hood. And this is interesting because so the researchers that I worked with, they had a collection of 40,000 of these stories, and they had a really large backlog as well, and it took a lot of time to enter these stories into the database. So this has a practical applications of just helping them to speed up the process. But also, of course, you can then also analyze these stories on a larger scale to see if certain patterns emerge in the data. So the first thing that we tried was, well, can we just, as I said, automatically identify these tail types? And these tail types are just these, like the vanishing hitchhiker, etc. And we framed this as a ranking approach. So given a new story, we want to have a system that would return a ranking of the tail types that the system thought was best. So it could say, well, first place would be Little Red Riding Hood, for example. And the nice thing is that then you can just take the top ranked tail type as the correct answer, but you can also just show the ranking to people to help them speed up the process without making a decision, complete decision automatically. So we tried different system architectures, but this was actually the most efficient one, where for all these stories we had lots of different variants. We put them all into one big collection, and then given a new story, we just try to find the story in the database that we already have that is most similar to the new story. And then we would look at the categorization of the story that was most similar to then label this new story. So if a new story comes in and then it's very similar to a story in the database that's already categorized as Little Red Riding Hood, we would say, well, Little Red Riding Hood is the label that you want for this story. And actually this gives you a pretty good accuracy already. If you just look at the top ranked results, it gives you 76 to 82% accuracy on the data. And mean reciprocal rank is just 1 divided by the rank of the correct answer. And there we got 0.81 to 0.86, which means that most of the time the correct answer is on the first or second place of the ranking. However, when we looked at the errors that the systems was making, we did also notice that there were some inconsistencies in the scheme and the annotations, as well as this whole notion of similarity as a binary one was quite limiting, because sometimes we would look at the system output and then would say, well, maybe the human label says this, but actually what the system proposes is not actually that bad as well. And so it really made us think a little bit more critically about the annotations that we already had and the scheme that we were using. And so then we decided, well, we want to understand this a bit more, because if you somehow want to measure the similarity between stories, it's a very tricky thing to do, because what determines similarity, right? And so, well, we have again 2 stories. The first one is some men sat around a fire. 9 cats came to sit near the fire, and the men got nervous. One of the men threw fire at the cats with a fire shovel, and the next day 9 women in the village lay in bed with burnt buttocks. And the second story goes like this. Every afternoon, a large black cat came to sit by the fire in the kitchen. People knew about a witch in the neighborhoods. One afternoon, the cat came again. A woman threw a pan with hot oil at the cat's neck. And the next day, the neighbor wore a white scarf and she had burned her neck. So who of you think this is like really similar? It's like almost the same story. And who of you, could you maybe raise your hand if you think it's like really similar? And who of you think they share some similarities, but actually I would say it's quite a difference. Okay, yeah. So so we wanted to study how people perceive similarity. So we would present them with pairs of stories and then just ask them to rate how similar they found these stories and also provide a short motivation. And we did this with a bunch of crowd workers and also with 3 folktale experts. And so for the stories that I just showed you, here are some of the responses. So one person says, and this person gives a 2, not much except they're about a cat. Then one person says, they give a really extensive explanation. Actually, both narratives are about witches and black cats, etc. But in the end, the content differs, therefore I give it 4 out of 5. And then maybe you would guess that these last 2 are actually provided by the experts. And they both say, well, it's just the same story. And this one actually says it's the same story because there are 2 narratives of the same type. So I highlight a couple of things. So one only mentions the cats, the other one mentions both witches and black cats. And these ones really mention the overall goal of the stories, and then say, because the overall goal is the same, it's really actually the same story. So we asked 80 crowd workers to do this task, and also we asked 3 Folktale researchers. And it was really interesting. We found that many dimensions play a role. So it's the characters, but also location, style, etc. We found that non-experts definitely paid more attention to the details. Well, the Folktale researchers would say, well, if they have the same goal, the same team, sometimes it's just the same story. But it also highlights that how you want to measure similarity using computational methods, for example, really depends on the goal and the end user, right? So if you're developing a system for these Folktale researchers, we probably want to use this categorization scheme that I just talked about, and perhaps also this notion of binary similarity might be appropriate for them. But if you want to develop a system, for example, for the general public to navigate your collection online, maybe you would need to consider other aspects as well in determining similarity. And actually, we also found some disagreement between experts, which I found interesting. Again, highlighting that these categorization schemes are really, really useful, but also not perfect. Yeah, and then finally, I want to talk about some of the challenges that I encountered in doing this research. So first of all, what I talked about was 2 cases where I used supervised machine learning, right? So this is where you start with a data set that has some labels. For example, social media messages labeled by whether they contain hate speech or not, or email messages labeled by whether they contain, whether they are spam or not. And these labels are really used to train as well as to validate your model. And so these labels are really crucial in the end in what you get, right? And so sometimes we notice, well, labels can contain errors. If it's just a bit of a sloppiness by the annotators, it might be not too bad, but if there's really true bias in the way how these labels are generated, it's going to be much more problematic, right? Because if these labels are biased, then your model will get biased, and then any measurements or analysis that you can do afterwards will have the same problem. Also, what I really came to realize more when I collaborated with social scientists and humanities is that this whole notion of ground truth is actually not something that a lot of them are familiar with, I would say, especially humanities researchers. So the idea that there's a single right answer, can be quite foreign and not always applicable to the type that you're looking at. Especially when you're looking at social and cultural concepts, sometimes the boundaries are not really clear, or sometimes it's not really clear what the right categorization is. And this is really different than when you're developing a system to just detect spam or not spam, right? In these cases, it's probably true. But in a lot of cases, when you're working on these social and cultural questions, I think we have to be much more critical about the data in the way that we generate the data, but also when we evaluate the model. And so I work in natural language processing. And of course, this is simplification, but in natural language processing, there's a really huge focus on how good these models do on certain tasks. So if you have these labeled data, you can then calculate measures like accuracy, F-score, precision, recall, etc. And to publish in good natural language processing venues, you really need to be state of the art. This is what most people will care about the most, if your numbers are good or at least better than previous systems. And so Chris Manning, in his article in 2016, says, well, there's been an overfocus on numbers, on beating the state of the art. And this is quite different from, I would say, the goals of social sciences and humanities researchers, where it's much more about describing a phenomenon, explaining what you're seeing. They think much more about, I would say, theory, causality issues, and interpretability as well. And so as a result, if you look at the type of models that people tend to use, you will see that in natural language processing, a lot of the models make use of thousands or sometimes millions of variables. These models can be very powerful, but also as a result, they can be kind of a black box. Sometimes you don't really know why the system assigns a particular label to a given text. In contrast, in the social sciences and humanities, the models tend to use a much smaller number of variables, and as a result, the models are much more interpretable. And so I think to really leverage the power of NLP, because NLP can really make really powerful models, we need to have NLP models that are a bit more interpretable as well. Because sometimes we develop really powerful models, but then they are not really used in social science, for example, because people are not able to interpret the models or understand what the model has done, and then they don't want to use it. So the last couple of years, there's been a lot of interest in the machine learning NLP community to develop more interpretive models, also for ethical and legal reasons. But I think it's also really important in this particular space. For example, if you have interpretive models, they can support theory building explanation, but also review incompletenesses in the problem formalization. So just how we define a particular concept, how we then develop categorization schemes, etc. This can be really difficult if you're dealing with really complex concepts. But then if you have an interpretive model, and then if you can kind of understand what the model has learned, sometimes it shows you limitations of how you had set up the task in the very beginning. Also, they can support error analysis and feature discovery, and also review biases in the data, because a lot of the data that we work with will contain some biases, especially when you're working with social media data. It's, I would say, almost impossible to control for everything. Think of topics, time, geography, social groups, etc. But then it could be that these models pick up on certain biases, and then it looks like they're doing really well, but actually they're using features that you wouldn't want them to use. But then if you have an interpretive model, then you can understand how they make their decisions, which could then point you towards biases in the data and how you might want to address them. Another thing that I'd like to just throw out there is that errors might actually be meaningful. So in NLP, we tend to really focus on improving the performance, getting 100% accuracy something. But actually errors can be really interesting. So sometimes they point toward cases that deviate from global patterns. So in machine learning models, they pick up on global patterns. But then when they're finding something that maybe doesn't match what the human has annotated or doesn't match the overall model, these could be actually really interesting cases, like a social media user that is deviating from community norms or other types of patterns, which you can then use for closer qualitative analysis. And also errors might point you towards inconsistencies in the classification scheme, like I described with the folktales. So error analysis is not only useful to improve your models, but it can also, I would say, shed light on your data to generate new insights about the data and the phenomena that you're interested in. And finally, I'd like to stress that I don't think these automatic computational methods are going to replace the other methods that people are already using, but it's really a complement. I think we both have strengths and limitations, and also it's a continuous iterative process, right? So automatic methods can help discover interesting instances that maybe qualitative researchers or other researchers can look at, but also their insights can then feed back into the computational models. And I think that's it. So to conclude, I think we're living really exciting times. There's a lot of new data sets available, really big advances in natural language processing and machine learning. So really exciting opportunities to study language and social behavior at a really large scale. But also there are lots of challenges left. And what I described today, I think, is one of the core parts of analyzing text and social cultural data, which is this operationalization process. And that's, I think, where both NLP as well as social scientists really need to interact with each other to make really rich and valid models. And that's it. Yeah, thank you.